All right, I want to welcome Tony Moore, who'll be talking to us about spatialization of graph data, making it plausible for geomorphological data. Welcome.
Thanks, Anne. So here I am once more. So this presentation is about music, even though the title doesn't suggest that. Music's going to be used as an application for spatialization. And as the title suggests, we are trying to explore fundamentally ways of getting music data, specifically the data about bands and musicians and their links in the form of graph data from a non-spatial domain into a spatial domain. That's spatialization. So as an example of spatialization, a very abstract level, here we've got 6 hypothetical work projects. It could be in any domain. It could be a university curriculum. It could be a student with their courses. It could be in Esri, where an employee has 6 projects on their plate at this time. In spatialization, we move from the left-hand side here with non-spatial data. We can assign, in this case, arbitrary spatial locations in some abstract space, place them as points in that space, and basically use a Voronoi technique to partition space as a weighted Voronoi technique. And that partitioning, the weighting, is dependent on one of the attributes in the aforementioned table. So in this case, it might be the length, the anticipated length of time of the project. The bigger the amount of time, the more area it takes up. And then you can use the third dimension to, within those partitions, create these hills and suggest terrain. And the height of the terrain could be linked to another attribute. In this case, it's some kind of user-defined assessment of difficulty of the project. So that's a simple model, and you can add to that basic model with some refinements. So here we've got not only projects, we've got the same 6 projects, but within each project, of course, there are tasks, subtasks within their stages to the project, and each one could be given its own duration and difficulty. And so we can have sub-partitions, creating a much more what I'll call plausible surface. And really what we're trying to create here are surfaces that we see out in the natural environment, a landscape that we know and recognize. And we can add other attributes, so we can actually roughen up the surface a bit. And this is using a kind of Brownian motion algorithm. More times than not, it will create a rough surface like this. Sometimes it might come up with something, maybe a face like Mount Rushmore. You might have Richard Dreyfuss embedded in the rock here, but it will produce more often than not a basic rough surface like this. You link that roughness to perhaps the certainty with which the user has perhaps estimated how much time a project will take, and how much difficulty a project will have. And that certainty might be, more certain it means more detail equals more roughness. A smoother surface suggests less certainty. So what you might end up with is this thing here, which may look like a plausible landscape, but is it truly geomorphologically plausible? It may suggest landforms in form, what you can see, but behind it, are there geomorphological processes that lead up to those landforms that are plausible? And having just gone through this myself, I'd say not. So this is really about imbuing this process with some geomorphological process knowledge, but at a naive level. So this is not the geomorphological knowledge of the vast majority of people in this room who've been through a geography curriculum and been through geography 101, 101, physical geography 101, and specialised perhaps in coastal geomorph and so on. This is really the knowledge of geomorphology shared by the population at large. So that's what I mean by when I say naive. So the application, this is where the music comes in, is the Dunedin music scene. So I'm from the University of Otago in New Zealand. Back in the late 70s through to the early 90s, there was this thriving music scene, which had international impact in certain places. Maybe not here, I don't know. And it had lots and lots of musicians and bands. Musicians, I know this guy, I've seen the data, there's one musician who played for as many as 11 bands. And together they create this vast network of nodes and links. And it's this that I want to explore, taking to a geomorphologically plausible environment, using two examples, orogenesis or mountain uplift or mountain building, and the concept of a young volcano as it becomes steadily eroded, having been created. And I'll end up with some concluding thoughts. So spatialization originates in GI science with Sarah Fabricant and also Andrei Skupin, and they defined it formally as a data transformation based on spatial metaphors. And here we're looking at the map and landscape as spatial visual metaphors for generating cognitively adequate graphic representations. And here's a few examples. This is the kind of naive landscape I'm really referring to. Here's one of Sarah's early efforts with spatializing news stories, with the locations of news stories having some kind of semantic meaning. So news stories that are related to each other are close together in the landscape. And here's a spatialization of the Exploring Geovisualization book done by Sarah and Joe Wood, where themes in the book are given a place with the authors as point locations, and themes that are close together semantically are close together in the map. So we've got lots of applications to spatialization. I've shown you a couple. Lots of others try and map spatially corpuses of documents. And the main aim of this is to reveal hidden attribute relationships in particular. Space and time are pretty much taken care of. And so we use metaphors to do this. And given that we are dealing with landscapes here, I've chosen to talk about landscapes and topographic maps. It makes sense that those metaphors, if they are to be cognitively plausible, they have to be geomorphologically plausible. And there are lots of techniques which I won't go into in order to make that transform from non-spatial to spatial. Lots of techniques use the self-organizing map. Here's a music one actually from Biberstein and Skupin and co-authors. And this actually covers music genres where music genres that are close to each other are close to each other in the map. And so you might have a musician, for instance, who's dabbled in both jazz and funk. And if lots of musicians do that, then inevitably through the SOM process, they will become close together in the map. I want to particularly draw attention to the last one. So I've already mentioned that I'll be dealing with graph data, node link data of musicians and bands. And I want to explore its spatialization through a generalized Voronoi process, multiplicatively weighted Voronoi. Never got the hang of that word. So we go from points. We do that weighted Voronoi, multiplicatively weighted Voronoi process, and we apply a simple mathematical function. In this case, basically a function that creates an S-shaped or sigmoidal profile as you go from the base of the slope to the top of the slope within each of the partitions. And you might end up with something like this, a simple version, which I've arbitrarily put into a virtual environment here. And here's one that's based on real data of the curriculum where I teach. So I come from a school surveying, and the Bachelor of Surveying second year curriculum has been spatialized here. And here we've got all those dimensions of basically duration. They're all the same. So they're all approximately the same size, these islands. Each island is a course. We got difficulty in there. Exams are regarded as most difficult and also the most uncertain too. And so we've got kind of rough looking peaks there. You might notice that one course over here, the lecturer didn't give me any information, so it's totally uncertain. And so that's really spatialization intro kind of taken care of, and applying those techniques to the Dunedin sound music scene. Really inspired by seeing this chart, which was drawn up as a kind of Gantt chart of bands in the Dunedin music scene from 1977. You got the band duration here. The Enemy, for instance, you can see here, started up in 77. Thank you very much, and kind of ended early in 78. So this gives me a bit of a duration and also an absolute time to play with in my spatialization. What you don't see are actually this small text here are the list of musicians within. And Bob Scott, who drew up this chart, is actually one of the prominent musicians in the scene. He lays down a challenge around here saying, I haven't bothered to draw the links. How could he with a chart like this? You know, it'll be a mess. But I haven't tried to draw the links between bands and musicians, so I'll leave it to someone else. So this is what we did. And we produced this for a recent exhibition in Dunedin commemorating this music scene. That's the chart there. So this is a classic graph. The coloured nodes are bands. The other nodes are musicians, and you can see via the links what bands they're linked to. And so it's this that I want to take from the graph world, which in itself is a kind of 2D spatialization, through to the landscape world. And I want to do this, I'm proposing to do this via one of the maps of the time. So style it according to this topographic map here, with basically bands being peaks in the map and musicians basically occupying the valleys and the coals or saddles in between. So this is the Lin's NZMS1 map series from 1979 of Dunedin, which is my home city, and the local natural area, which incidentally is a extinct volcano in the middle of the harbour here. I hope it's extinct. And so this is a schematic of how this might turn about with the actual bands themselves corresponding with peaks and the musicians in between. So that's basically an expression of intent. I'm just going to finish off with a couple of schematics of how this might come about. So I mentioned mountain uplift or mountain building, orogenesis. It works on a scheme where earlier the band is, the higher the peak. The wider the peak is, the more the band was in existence. The duration is more. Okay. And so first off, one by one, in temporal order. So with the first band, you saw it as the Enemy there. I would add that into the landscape as a point. Calculate its Voronoi. So for this point here, the Voronoi has got one polygon basically. And then keep on adding from earliest to latest. And then for each added band during their time of existence. So I've kind of run a clock here that started in 1977, and each band is being added at the time that they came into existence. You can see the first band here, the mountain building's already started. So we've got the mountain growth. You don't see it, but there is an opposing force of, I call it erosion, but it's really an accumulation of a surrogate for erosion and weathering and mass movement and all the other stuff that happens to these landforms. And then the band at some point ceases to be, at which point growth outwards stops, but mountain building carries on. And so we still get the sense of how early the band is by the height in the landscape, but we get a sense of how perhaps short-lived or long-lived it was by its aerial presence in the landscape. And in a similar, but with one key difference, we've got a young volcano scenario where the band starts off as a tall young volcano, boom, it's there in the landscape. And then we've got those forces of erosion and mass movement and weathering actually acting on the volcano, bringing it downwards. So basically, the lower the volcano is in the landscape, the older the band is, which perhaps is the more geomorphologically plausible scenario in this case. And the force of spread operates while the band's in existence. So there's a similar background timer going from 1977 to 1993. And so with the same scenario, this is what might happen. You see the original volcano here descending down to a slightly smaller volcano as erosion happens. And then at this interval, basically this band ceases to be and the volcano doesn't spread anymore and spreads through eruptions. So in summary, just a quick summary, spatialization, it's been well established as a powerful way of expressing non-spatial phenomena. It borrows on our affinity with maps and landscapes. I've presented some naive geomorphological solutions, and these are designed to broaden understanding and tease out relationships with these musicians and bands. So there's promise of revealing insights, but there's a lot of work to be done. So, for instance, I just presented 2 geomorphological scenarios. There needs to be a more authoritative body, a kind of some kind of move to basically what is the ontology of naive geomorphology? You know, you go to the person in the street and ask them, you know, what do you know about landforms and their creation, and try and get a kind of common sense consensus of what that is, and that can go in here. So having established that, then there'll be some kind of usability assessment of how usable people found the spatialization. So thanks to many people. So got Alex and Ken and Linda who contributed this week in no small way to refining these arguments. Also Mark and Mike for helping develop the spatialization technique I showed earlier. Also Ella, Amanda, and Catherine and Neil for their involvement with the exhibition of the graph and the wider ephemera of the Dunedin music scene. And thanks to you all for listening, and thanks for staying so long. Cheers.
Thank you very much, Tony. That was really interesting. I guess Gaurav's not in here. That's too bad. Questions? Ethan, did you have a question?
Maybe you mentioned it. Did you look at incorporating the graph relationships into the orogenesis rendering?
I didn't mention it. No, it was hidden in the slides. I glossed over it. It's actually in that last slide. There is actually another metaphor at play here, which you often get with topographic maps, which is, of course, on top of the terrain, we have the human man-made network of roads and tracks and so on. And this is the way in which I intend to convey the links between the musicians and bands. Yes. So really, this was concentrating purely on the base terrain and how that's created. But ultimately, there are 2 parallel avenues of communication metaphorically. One coming from the landscape, and one coming from the network that dwells on the landscape. Something that topographic maps does very well.
Affecting orientation or something.
So, orientation, you say?
Yeah. So I was thinking maybe the relationships affecting the orientation of the peaks.
Okay. Yeah. Orientation is not kind of high up in my list of considerations. So I'm more interested in proximity. So in whatever direction one musician is relative to the band that they're playing with, as long as the musician is relatively close to that band, I'd say that key relationship is captured and communicated through the spatialization. One thing I didn't mention either is I actually want to squeeze this non-spatial data into the coastline around Dunedin, so that it might inevitably affect orientation. But no, I'm not going to have it uppermost in my mind. There won't be any line of code that will make sure one thing is oriented consistently north relative to another thing. Yeah, thanks.
Great, thanks. I'll just point out that Gaurav Sinha, Ohio University, who's not here, along with several folk at USGS, including me, have a reference landform ontology that it does have a naive component to it. So it's based on shape and how people, what shapes of features make them think this is a mountain, would be called a mountain, or so it's something maybe to look into.
That's excellent. Yeah, I'll please.
Great.
I'll get it from you. Yeah.
Okay.
Thanks a lot.
Other questions?
Thank you. This is really interesting and intriguing idea. My question is kind of naive and probably wild, doesn't it? It might be just nonsense. So you have, there are some rules like you talk about earlier is higher or earlier is lower, right? So you have to play with different rules, and that might have that will definitely have the impact on results. So I was thinking, how do you evaluate? How do you know which is better? So I was thinking, if we try it backwards, if you have real landscape, according to your rule, you go back, translating from landscape to music, how would that play out? Have you ever thought about it? I was just curious. Thank you.
Yes. So actually the answers are on this slide, which I only glossed over. So in the grey text here, number one, your usability points. Yeah, the last point here is ultimately I'd like to kind of present a landscape, say, based on young volcanoes, another one based on mountain building, to users, and basically put them through tests of efficiency, how fast they can perhaps find a musician and a band across the landscape, and the ones that link to effectiveness, how correctly they do the same, and ultimately their opinion, satisfaction. So what do they think of young volcano scenario versus mountain building scenario? So the usability test here, yeah. And this point here, which is a very good one. Rose out of a conversation with Alex and Ken and Linda this week. Was ultimately, you're right. The application of music, same if I was going to do the same with fine art and so on. Ultimately, the creativity in music is reflected in the kind of creativity in making abstract space from nothing. In these kind of hopefully plausible ways. Definitely. Thank you.
Wonderful. Any more questions? Nothing online? Well, thank you so much. And thank you everybody for joining us in the session. It's been wonderful. Appreciate you staying around so late on a Friday after a very busy and productive week. And I believe we'll be having closing sessions here in after the break, I believe. So thank you.